All right. Where's my pen? Oh, here it is. All right. Lecture 23. All right. Radical equations. Part 2. Cube roots. Yep. All right, I think that's what we're doing. Yep. Let me put that in parentheses. There we go. Okay, so last time we were talking about radical equations, right? During part 1. But part 1, we were talking about square roots, right? So today we're going to be talking about cube roots. And I don't really have a definition today because we already did the definition last time. So I'm just going to go over radical expressions again. So note radical expressions. Okay, so for any radical expression, you are going to have a radical sign. You're going to have something inside the radical sign. Let's just call it x for now. And you're going to have an index, which is a number on the outside. So I'll just put an n on the outside. Okay, so this is the index. That's going to be the number on the outside. And whatever's on the inside is called the radicand. And then the sign itself, this is going to be called the radical sign. Okay, so for any radical expression, there's going to be 3 components to it. There's the index, there's the radicand, and then there's the radical sign. So today we're going to be talking about cube roots. So cube roots are radical expressions, but instead of having an index of 2 like the square roots have, cube roots are going to have an index of 3. So they're going to look like this. Cube root of whatever, right? And there are a couple basic cube roots that you should know. There's the cube root of 1, the cube root of 8, the cube root of 27, and how about we just go down the list, right? You also have cube root of 64, 125, 216, and we'll stop at 216. How about that? Okay. So all 6 of these numbers that are under the cube roots, they are called perfect cubes, right? These are numbers that when you take the cube roots of them, you're going to get whole numbers. So the cube root of 1 is obviously going to be 1 because 1 times 1 times 1 is equal to 1, right? And then the cube root of 8, that would just be what? 2, right? So the cube root of 8 is 2 because I know that 2 times 2 times 2 will give me 8. So then just going down the list, I know that 27 is a perfect cube. If I take the cube root of that, I'm going to get 3. So the cube root of 27 is 3. I know that because 3 times 3 times 3 will give me back to 27. Okay, so now let's do the last 3. The cube root of 64 is going to be what? 4. Because 4 times 4 times 4, that's going to get me 16 times 4, which is 64. So I'm right back where I started. Cube root of 125, that is going to be 5. Because 5 times 5 times 5, That'll give me 25 times 5, which is 125. And then cube root of 216 would be 6. And it even ends in a 6, right? I'm sure that's just a coincidence, though. 6 times 6 times 6 gives me 36 times 6. That is 216. And the list goes on, right? There's an infinite number of perfect cubes out there. Okay, so those are cube roots. I'll zoom out so you guys can get the rest of them. And I'm going to get ready with another sheet of paper, and we're going to cover cube root equations in just a minute. Okay, so cube root equations, these are always going to have an index of 3. Whereas square roots, the kind that we were doing on Monday, those have an index of 2. And usually if the index is 2, I don't even write the 2. So I'll just write a square root with no index to it. And you're supposed to know, oh, the 2 is assumed to be there if it's a square root. But if it is a cube root, then you're going to see the index of 3 on the outside. Okay, we're going to be looking at the problem set today. And I'm going to be starting with number 2 on the problem set. And I'll show you how to solve a few of them. And then we'll go back to square roots for a little bit. Okay. Let's look at number 2. And I'm going to zoom in so you guys can actually see what I'm writing. There we go. Okay. So number 2 says the cube root of x minus 8 equals 2. Okay. So I know I'm dealing with the cube root because my index is 3 on the outside. So what I'm going to be doing is I want to get rid of the radical first because there's nothing really around the radical that I need to worry about. So getting rid of the radical, that'll get the x minus 8 on the outside. Okay? So the first thing I'm going to do is I'm going to eliminate the radical by cubing both sides. So I'm going to put this whole radical expression inside parentheses. And I'm going to put the exponent 3 on the outside because I'm cubing both sides, right? And then on the other side, I have a positive 2. I'm going to put that in parentheses as well, just like last time, and I'm going to cube it on the outside. So what's going to happen is the cube root and the cube on the outside are essentially going to cancel each other out. So I'm really just left with whatever's inside the radical sign. And whatever's inside the radical sign, don't change it, don't do anything to it, just bring it out. So the x minus 8 is going to come out just as it is, don't change it. The right side is going to change though, because I've got 2 to the 3rd power. And we know that 2 to the 3rd power is going to give me 2 times 2 times 2. That's going to give me 8. All right, so I'm almost done. I just need to get x by itself now. And the way I'm going to do that is to get rid of a negative 8, you have to add 8 to both sides. So once I add 8 to both sides, can you see what my answer is going to be? It's going to be 16. Okay, so once you got your answer 16, you put it inside the solution set. So I'm going to draw my solution set, put a 16 on the inside, and then close it up, because that's the only solution for this equation. Okay, so not so bad, right? All you're doing is you got to get rid of the radical by cubing, and then you get x by itself somehow. All right, so now let's check our work. I'm going to do this on the right side. So what I'm going to do first is I'm going to write out my original equation the way I see it. So the cube root of x minus 8 is equal to 2. All right, so the answer that I got was 16. So what I'm going to do is everywhere I see an x, I'm going to replace it with a 16. So I'm going to get the cube root of 16 minus 8 is equal to 2. Once again, the only thing I'm doing is I'm replacing that x with a 16, whatever answer I got from the left side. Okay, so how can I simplify this a little bit? Well, I've got 16 minus 8. I know that 16 minus 8 is just going to give me positive 8. So really, I've got the cube root of 8 is equal to 2. And then, of course, the cube root of 8 is 2. So I get 2 equals 2. And that's a true statement, right? 2 is equal to 2, right? Yep. So if you get a true statement, that means that your answer is correct. Now, if you got something like a false statement, like let's say 2 is equal to 0, then maybe you need to go back and see if that answer really works out and where you messed up. But if it works, it works. Okay. Let's look at number 3. All right, 3 says the cube root of x. So I'm taking the cube root of x, but first of all, I'm dividing everything by 3 is equal to 2/3. Now I've got a fraction going, but that's really not a problem because what you'll see in the first step is that fraction is going to get canceled out and it's going to become a whole number. But how do I start this? Well, I could start off by cubing both sides. That would definitely get rid of the radical right there. But the problem is I've got that 3 under there that's kind of blocking the way. So if I could get rid of that 3 that's underneath, then I can cube both sides and I can get an answer. So I need to get rid of this 3 that's in the denominator. So how am I supposed to do that? Well, starting off, I'm basically dividing this radical by 3, right? So what's the opposite of dividing? Wouldn't that be multiplying? So I'm going to multiply both sides by 3 to get rid of that 3 at the bottom. So I'm going to multiply both sides by 3. I'll put a 3 over here, and I'm going to put a 3 in parentheses right here. I know I got a whole lot of 3's going on, right? But these 3's are going to cancel out, and these 3's are going to cancel out. So what happens here is the radical is going to come down as cube root of x, and then on the other side, I'm just going to have 2. So the cube root of x is equal to 2. Now what I can do is I can put everything inside parentheses and then cube both sides. That'll get rid of that cube root right there. So I'm going to put everything inside parentheses, cube both sides, and see what I get. Okay. So now, once I cube both sides, the cube root and the cube are going to cancel each other out. The x is going to come out. And 2 cubed, that's going to give me 8. So I put 8 inside my solution set. All right. So I know my answer is 8. So now when I check it, I'm going to rewrite my original equation. That was cube root of x divided by 3 equals 2/3. Now, wherever I see an x inside my original equation, I'm just going to plug in 8. So I'm going to get the cube root of 8 divided by 3 is equal to 2/3. All right, so far so good. All I'm doing is I'm replacing x with 8 because I know from the left side, x and 8 are the same thing, right? That's what that equal sign means. So now I just try and simplify a little bit, see if I can get both sides equal to each other. I know that cube root of 8 is 2, so really this is 2/3 over here. And since I have 2/3 on both sides, I have a true statement. So I know for a fact that this 8 over here is going to work. All right. So now I'm going to skip to number 5 because that's when the next cube root question is. So we're going to do 5 next. 5 on the problem set. Okay, so number 5 says cube root of x is equal to -2. Okay, so I've got the cube root of x is equal to -2. And if you watch my previous lecture, I told you guys that if you have a square root, now we're not talking about cube roots now, we're talking about square roots. If I have the square root of x is equal to a negative number, then that would be no solution, right? Now, this is because if I try to find the square root of any number, I'm not going to get a negative number. But that's not the same way for cube roots. You can actually find a number that when you take the cube root of it, it'll be negative. And you probably already know what that number is. So let's try number 5 together. The first thing I'm going to do for number 5 is I'm going to cube both sides. That's pretty much the only thing I can do at this point. So I'm going to put both sides in parentheses, and I'm going to cube both sides. That'll get rid of the cube root. Make sure you include the negative inside the parentheses. That is very important. So now cubing both sides, I know that the x is going to come out just the way it is. The cube root and the cube are going to cancel each other out. And then I have -2 cubed. So what would that be? That would be -2 times -2 times -2, right? So I'm basically just writing -2 3 times because I'm cubing it, right? Okay. So -2 times -2, that's going to give me +4. +4. But I've still got another -2 that I have to deal with, right? So this is actually 4 times -2, and that's going to give me -8. So x has to be -8 for this equation to work. So inside my solution set, I'm going to put in that -8. Okay, so I know my answer is -8 now, but how do I check it? Well, I check it just like any other equation. I write out the original, not changing it, and then everywhere I see an x, I'm going to plug in -8. So where this x is, I'm going to plug in -8, and then the cube root of -8 is indeed going to be -2. So I get -2 equals -2. And I'm done. So what's the difference between, let me get my red pen. What's the difference between this one right here, as it is, and this blue equation over here? Let me get my blue pen. What's the difference between this and this? What do you guys think? What's the difference between the red equation and the blue equation? The only difference between these two is one of them has a different index, right? This equation in red, this one has an index of 3. Over here, the equation in blue, this one has an index of 2, right? This one has a square root, this one has a cube root. Now, you can take the cube root of a certain number and get a negative answer. That's fine. But if you're taking the square root of any real number, you're never really going to get a negative answer for that. You're always going to get either a positive number or 0. It's never going to dip below and hit a negative number. So let's see why that is. Before I move on to the next few questions, what I'm going to do is I'm going to go over to Desmos and I'm going to see if this actually works. So just hold on. Let me see. I hope this works. There we go. Okay. So now I'm in Desmos, and this is a free graphing calculator that is on a website. If you go on here, which you can also do on your Chromebook, you can just start graphing. Now, right here in this first box, I can put in whatever function I want. So I'm going to start off with f of x. F of x. So I've got f of x is equal to, and I need a square root, right? Well, an easy way to type in a square root would be SQRT. SQRT. And it automatically turns into a square root. So here, since the function is of the variable x, I need to put in x under the radical. And when I do that, you can see that a graph shows up on my screen. So looking right here, what you'll notice is this graph never really goes below the x-axis. Remember, the x-axis is the horizontal axis, and the y-axis is going to be the vertical axis right here. And what you'll notice about this graph is it never dips below the x-axis, right? Because it's always going to stop at the point 0, 0, which is the origin. So it's never going to go below the x-axis. So if I was to type in another function, let's say f of x is equal to -2. And then let me zoom out. What you'll notice is these two graphs are never going to cross. So square root of x is equal to -2. Since these two graphs never meet, they never intersect, that means that the equation that I have over here, square root of x is equal to -2, has no solution to it. So going back to my paper over here, I see that square root of x is equal to -2. Since those two graphs never cross each other, that's another indication that this has no solution. But what if I was to graph the red equation? Let's try that. So I want to graph the cube root of x now is equal to -2. So what I'm going to do is I'm going to go back to Desmos. There we go. And instead of having a square root of x, I want a cube root of x. So I'm going to delete this, and I'm going to pull up my keypad that's at the bottom. At the bottom, you'll see an icon that says Show Keypad. I open it up, and I want to get a cube root somehow. And that's actually going to be under Functions, I believe. So I go over here to Functions, and I know it's not going to be under Statistics or Distribution or Trig or any of that stuff. If I go to Miscellaneous, I see that I have a cube root right here. Now the index is n, so I can pretty much replace the index with whatever I want it to be. I'm going to choose 3 since it's a cube root, and I'm going to put x under the radical. There we go. So what you'll notice is this looks completely different from what a square root is. When you graph a cube root, this graph is actually going to go up, and it's also going to go down if you go to the left. So moving on to the left over here, what you'll notice is the red graph and the blue graph are going to intersect right here, which is the point -8, -2. So since these graphs actually cross, I know that going back to my equation over here, where is it? Let me get it. Going back to my red equation right here, this actually is going to have a solution. It's going to be -8. So that's why, when you have a square root, you're never going to get a negative answer. But if you take the cube root of a negative number, you can get a negative answer. So that's all I'm trying to say to you. Square roots and cube roots are completely different when you graph them. Okay, let's do 4 more problems. And I'm going to go back to number 1. Okay, are you still with me? I hope I didn't bore you to death, but sometimes you got to say something that's really important. So let's go back to number 1. Let's do the square root of x is equal to 10. Okay, so I've got a square root this time, which means I'm not going to cube both sides. I'm actually going to square both sides. So squaring both sides is going to give me square root of x, square that, 10, square that. Whatever's inside the radical is going to come out unchanged. And then over here, I'm going to have 100. So then I put that inside my solution set. Okay, let's check it. So I write out my original equation, and then I replace x with 100, and I know that the square root of 100 is 10. So this is actually going to work out. All right, so that's number 1. Let's look at number 4. 6 plus square root of x is equal to 11. Now, this is one of those situations where you can't really square everything first because this plus 6 is in the way. So if I could get rid of that plus 6, then I can square both sides and get the x out of the radical. So let's do that. I'm going to subtract 6 from both sides. So I get square root of x is equal to 5. Good. So now I can square both sides to get rid of the square root. So square both sides, the x is going to come out, and I'm going to get 5 times 5, 25. So inside my solution set, I am going to have a 25. All right, so now I can check it. I write my equation out like usual. Don't change anything to it yet. And now that I've written out my original equation, I can plug in x is 25 and see what happens. So I get 6 plus square root of 25 is equal to 11. Again, I'm just replacing x with 25 and seeing what happens. So the square root of 25 is going to be 5, right? I get 6 plus 5 is 11, and 6 plus 5 is 11. So I get 11 equals 11. So that answer does work out. Okay, let's get on to the last two, 6 and 7. All right, let's do number 6. So this one is kind of strange because you haven't seen something like this before, but you probably already know how to do it. I got the square root of 2x minus 10 is equal to the square root of what? 14 minus x. And I'll zoom in so you can see it a little better. There we go. So for this one, I've got 2 square roots, right? One on the left side, one on the right side. There's nothing else that's around them that I can see. So I'm just going to start off by squaring both sides. That'll get rid of the square root at least. So I'm going to put this side in parentheses and square it. And I'm going to put this side in parentheses and square it. That'll get rid of the square root. Okay. So I start off by squaring both sides. And whatever's inside the radical, we keep that the same. We bring it out. So the 2x minus 10 is going to come out. and it's going to be equal to 14 minus x. So far, so good. Nothing really challenging yet. So now I've got an equation where I have x's on both sides. So what I'm going to try and do is get all the x's on one side and get all the regular numbers on the other side. So using blue for a second, what I want to do is I want to get this x all the way over here, right? But I want to take this 10, and I'll do this in red. I want to get this 10 all the way over here. So that way the numbers can be on one side together and the x terms can be on one side together. So how can I do that? Well, to get rid of this negative x, I can add x to both sides. So I'm going to add x. Good. And then how do I get rid of that negative 10 on the left side? Well, since it's a negative 10, I'm going to add 10 to both sides, right? So I'm going to add 10 to both sides. Okay, so let's see what happens when I do that. All right, so the 2x plus x is going to give me 3x. And that's basically because there's an imaginary 1 out in front right here. So 2x plus 1x is going to give me 3x. Right here, the negative 10 and the positive 10 are going to cancel each other out. So these don't really matter. I bring down my equal sign. Okay. Now over here on the right side, what else is going to cancel out? Well, the negative x and the positive x, right? Those are going to cancel. And then 14 plus 10 is going to give me 24. All right, almost done. So now to get x by itself, all I need to do now is divide by what? Divide by the 3. So when I do that, what do I get for my answer? It's going to be x equals 8. So 8 is going to be in my solution set. Okay, so let's check our answer and see what we get. And I'm running out of room on the right side, so I'm just going to do it below the solution set. Okay, so I write out my equation just the way I see it. 2x minus 10, 14 minus x. And both of them are under square roots, just like they were when I originally found it. Now, since x is 8, I'm going to replace every x I see with an 8 and see if it works out. And if it doesn't work out, that's fine. It's just, you want to just check it just to make sure. So 2 times 8 minus 10. And then under here, I'm going to get 14 minus 8. All right. So now, let me zoom out a little bit. Under this radical, I know that 2 times 8 is going to give me 16. So really, I'm going to have 16 minus 10. Over here, I know that 14 minus 8 is going to give me 6. So under this square root, I'm going to have 6. And then, wouldn't you know it, 16 minus 10 is 6. So I get square root of 6 is equal to the square root of 6. Good. So that works out. Okay, so I get a true statement. That means that this 8 inside my solution set is going to belong there. That 8 is going to work. All right, I'll leave that up there for a minute, and I'll get my paper ready for the last one that we're going to do today. Number 7. So 7 is going to be one of those that is special. And the reason why it's special is because it has no real solution. So let me write it down and get it ready. Number 7 is going to be square root of x is equal to -4. Okay? So let's take a look at this one. So usually when I solve equations like these, I want to square both sides first because I want to get rid of that square root. So I'm going to square both sides. Make sure the -4 goes in the parentheses. So now when I square both sides, the x is going to come out of the radical sign, and I'm going to have -4 squared on the right side. We'll get to that later. So whatever's inside the radical is just going to come out because the square root and the square are going to cancel each other out. Okay, so -4 squared, that's the same thing as -4 times -4, right? Yeah. So what's -4 times -4? That would be +16, right? Don't let the negative trip you up. Make sure you multiply them together. So my answer is going to be +16. I put that inside my solution set. Okay? Now let's check it. So over here on the right side, we are checking our answer. I always check my answers for these because you never know when you're going to get a no solution question, right? So I write out my original equation the way I see it. So square root of x is equal to -4. Okay? Everywhere I see an x, I'm going to plug in my answer, which is 16. I get square root of 16 is equal to -4. But the square root of 16 is going to be +4. So I get +4 is equal to -4. So is this a true statement or is it a false statement? Well, it's definitely not a true statement. This is false. So I put not equal to. I just slashed through that equal sign. So I know that 16 does not belong in my solution set. So this is not going to work. My actual solution set is going to be the empty set, which means no solution. So the way you can write that is you can write a solution set with nothing in it, right? That's the empty set. You could also write it as this right here. This is a symbol in math. It just means the empty set. This is just an empty set. But usually the way your teacher is going to want you to write it is just by writing no solution. No solution. Okay? So I'll leave that up there for a minute so you guys can get that. And we're going to take 5 minutes and look at your homework. Okay. So looking at your homework, I think I've got, 7 questions. And we're going to take a look at that in a minute. Okay. So this is kind of a mix of square roots and cube roots. Do know that if you have a square root, you got to square both sides. And if you have a cube root, that means you got to cube both sides.